Hello, everybody, welcome back. Alright, where did we leave off last time? We had refactored everything into these new folders, model.js and engine.js, files. And we still have our index.js, which just basically sets up our board, passes in the box, and tells us how many rows and columns we should have. And then we had an output that was kind of ugly. Something was going on, and suddenly we have the entire row being colored in instead of just the specific cells that we want. So we need to figure out what's going on here. Time for debugging. Debugging is not it's not a process that you do afterwards. It's a continual integration. You are continuously writing code and debugging, writing code and debugging. There's no, yeah, you're always going to be doing, debugging along with all the rest of your stuff. It's a constant process. You're going to be going back and forth and doing it over and over and over. And yeah, there shouldn't draw a line between it. Debugging is just part of developing. Okay, so we need to figure out why. So we're going to look at our, so where could our problem be? So we have our game engine, which is telling our board, or we're telling each of our blocks that are in our board array to draw during this draw function. That's great. That's getting fired. And then our block, it has a draw function, which is for each coordinate in its shape, it's setting the it's calculating the x and the y coordinates, and then it is picking the column object, and then changing the background color to whatever the color of the shape is set to. Okay, this is great, but there is an issue. So I'm going to say that the issue is probably on this line here. Something else to check is how many coordinates do we actually have, to make sure we only have 4 coordinates like we should, and stuff like that. So, and make sure that our calculations are actually coming out correctly as well. So really what we want to do is debug this little block here. So that's what we're going to do. So since the engine is running and it's continuously trying to draw that shape over and over and over, I can just click down here, place a breakpoint, and it's automatically going to hit it because it's sitting here rerunning this every single time really quickly. So let's see what we have here. We have our well, really what I want to do is I want to try to grab this when it hits this block, because I want to make sure we're doing each of them in sequence. We want to do all of them. Alright, watch expressions. These are really cool. So what we can do is you can type in things that are down here, and they'll line up as soon as you actually have access to them. So I'm going to put a couple things in here so that we can just see what's going on. So self dot let's see, position dot x, self dot position dot y. I'm actually going to close all these up because they're kind of going to get in the way, and this is going to get really large. And then self, well, what we want is the calc. Well, we want the actually coord dot x. So we can remove this one because we're just looking at the x and the y. Coord dot y, and then we want calc, calcx, and then calc y. Okay. And then we want to see what object. Well, no, this should be enough information to give us. So what we're going to start doing is we're going to start stepping through. So we're going to step into the call. You'll see these things change automatically. So this is nice because you don't have to keep hovering over them. You completely can, but it gets a little annoying waiting for it to pop up. So it's all available right here. So let's do our calc x. Well, 0 plus 0 is in fact 0. That looks good. Calc y, 0 plus 0, 0. And then we're going to color our row, or sorry, our block. That looks good. So let's step through again. Our x coordinate is 1. Our position is 0, so we should get, yep, that looks right. 1, 0, 2, 0, 3, 0, and then we should exit, and we do. Okay, so we're going to continue on, and we're going to see what happens in the next time that we hit this. Because really what I want to do is figure out why is it highlighting the entire row instead of just each one. And the one thing I didn't do, which I need to do and should do, is we're going to remove this. We're going to remove these breakpoints so that we can actually get access back to the DOM. And then we're going to go in here. We're going to inspect our element. We're going to look inside of our cells, and we need to see why it looks like actually something's not lining up, because the style is set on the row and not on the cell. Okay, so that's our problem. Our problem's not in our mathematical calculation, but it's actually in our CSS implementation. Not CSS, but it's where it's setting. This object was getting set to the wrong thing. So we need to come back up here. Check this out. Call.pend. Oh, because the row.append brings us back the call. So what we need to do is change this around a little bit. So now we need to do var call equals just this. And then we need to append that to the row. Which can just be a call like that. And then that's going to give us a lot closer to what we want. So let's just refresh this. All right, that looks good. And boom, there we go. Perfect. We got our 4 blocks exactly as we want them. This is looking great. This is great. Now, the one thing that those that are observant will notice is this is not our 0, 0 block. This is our 20 block, right? So a couple tricks we can do. One is we could, probably the easiest way would be a preliminary step to just reverse all this stuff and reverse all the objects in the array. So let's look up some documentation. And we're going to do array and MDN. If you're looking for JavaScript documentation, I highly recommend putting this at the end of your query. Put the object name or whatever you're looking for and then do MDN. What it's going to give you is an error page because I apparently don't have internet. So we're stuck again. What do you do without internet? I guess we just play around. So array dot, I'm looking for a reverse function that can flip the array backwards. And I'm not seeing anything that is particularly helpful. Let's check the prototype. Concat filter for each length reverse. Aha. So let's test this out, right? So if we do let's do var a equals 1, 2, 3, and then we do a, we'll get 1, 2, 3, and then if we do a dot reverse, we get 3, 2, 1. Perfect. So that's exactly what we want. We want to reverse our columns are correct, but our rows are backwards. So once this generates, what we want to do is self.rows reverse, and because I can't look at the documentation, I'm just simply guessing is that it's not going to do it in place, which means that I need to reassign it back to the variable. Okay, so once we make that small one-line change and we reload and then we replace our block on the page, it's now at the bottom. So sometimes there's a really simple mathematical built-in way to do things, and sometimes you have to like completely change the way you're doing things to get this to work. So I'm really happy that this worked, and what I'd like to do now is we need to Okay, the thing that we have to do now is we're going to create a couple functions. Alright, so now we're going to start really getting into, this is simply just getting it on the screen. Now we're really going to start getting into the power of using these objects and stuff like this. You're going to see just how really nice this is. So what we want to do is we're going to do self.move. We're going to create a down function, right? So move down. Now, the draw function is already being called automatically, so we don't need to do any sort of DOM manipulation as far as redrawing it to the screen. The only thing we need to do is correctly adjust the position to successfully reflect a down movement. So in order to move down, what do we need to do? So if we're at the very top, our x will be, 19, and our y will be 19, and our x will be, I guess, 0 if it's at the left. So if we're moving down, all we're doing is editing the y. So self.y equals self, well, really we can just do minus minus. Really nice JavaScript shortcut. Just put minus minus behind anything and it decrements it. Basically does, this is the equivalent of self.y equals self.y minus 1. So it's a really nice shortcut to do just that. Okay, so now that we have a move down function, what we want to do is when we place the block on the board, we want to place it at the top. So we're still going to do 0 for the first block. We will do a 19. And sorry, we need to do a 0 still, and then we'll do a 19 here. Right? So that should give us a block at the top. So that's really what we want. So we're going to refresh, and we're going to place that block on the screen. Great. So now how do we call this? For the moment, what I'm going to do is cheat. Not really cheating, but just we're going through our steps, making sure our functions work. So blocks, I'm going to grab the first block, and then we're going to call the move down function. And what we should see is it does nothing because I don't know why. It didn't throw an error. Oh, maybe it doesn't have the code for whatever reason. So push a new block. Move down. No. You don't like that? Okay. Let's figure out what's going on. Is it even getting called? Is this even working? If we go back to console, oops. Yep, it's getting called. So what is y equal to? Self.y. Oh, self.position.y. Duh. Okay, so we have a little bit of an error in our code here. Alright, so yep, confirming yes, we do have that. We can remove that breakpoint because we want to see what happens. And what we should see is that's correct. So what we didn't do is we didn't clear back out this where it used to be. This is tough. When you're redrawing a screen, almost what you need to do is completely set everything again back to nothing. It's going to seem really inefficient, but that's just, that's how your computer monitor works. It redraws every pixel on your monitor so fast that you can't detect the change with your eyes. Or you usually can't. Some people can, actually. So that's kind of what we need to simulate with this, is we need to, when we call our draw function, we need to clear the entire screen. And this is where it can get kind of jumpy, and you might actually start seeing things blink. We're going to look into ways to make this more efficient, and we're going to look at maybe different techniques for doing this. And this is another reason why maybe having the blocks that hover over instead of actually fill and just set the background is a better way to go, because then you don't have to redraw the screen all the time. You just literally move the block. So we're going to do this for now. We're going to see what happens. So we need to go back into our engine, and when we call draw, it's going to refresh everything, but first we need to do a clear method. So we're going to create a clear method, function clear, and the clear method is going to take the entire board and reset all the CSS on it. So we're going to try to do this as efficiently as possible. So instead of looping through all of the rows and columns on the board, I'm just going to do a selector for cell. Everything that has a cell class on it, we're going to do .css and set the background color to white. And what we can probably just remove that, but we'll just set it back to white for the moment. Okay, so we're going to refresh this. Then we're going to put our block on, and then we're going to move it down. And as you can see, it actually works. And now we actually have something that actually is reflecting a true movement, right? So that's good. We're starting to really get somewhere. So we've got all these move down functions, we've got a move down function. So let's start implementing the other directions now that we see how that works. So we have a move down, and then we need what? A self dot move. Well, you can't go up in Tetris, so we don't need to do that one. Move right function and self. So when we're moving right, what are we altering? We're taking our X and we are increasing it. So we will do position X plus plus. And then when we're moving left, we will do self dot position X minus minus. And so that will now move us to the right and to the left. Awesome. Let's test these out. Refresh the page. Place our block on the screen. Check the blocks there. We're going to call our move down. We're going to call our move right. And then we're going to call our move left. Okay, great. We've got some actual stuff going on. I would go to the next stage and actually show how to tie these to key events, but I don't have internet at the moment, and I don't know the key codes for right and left and down and up and stuff like that, or any of the other keys, and I don't have the power of Google at the moment, so I sadly I will have to do that during the next episode. But I hope you guys kind of started to see why I went with class-based objects. why we did all of this, which seems really ridiculous at the beginning. Why did we create these objects which then handle this? Why did I go through the pain of doing all of this, refactoring this? And now we see the result. The result is you have really nice convenience methods that just say move right, move left, move down, and things just kind of, they do it on their own. So using this, it's called Object-Oriented Programming, OOP. And using these OOP type styles are really start to make manipulation of these things a lot easier. And as you can see, we have essentially a game that right now we can have blocks on the screen and we can move the blocks around in 97, so 897, 98 lines of code. So simple, so small. We're really not, we're really getting a lot of power out of something that's really not that much code. And now you don't have to think about the other advantage to having these, these convenience methods here, move right, move down, move left, is you now don't have to think about, okay, well, if the y is this, then I need to subtract. It takes all that out. You do this one time, you set up your one function that sets, you go through this, doing all this, well, how do I calculate the position and the coordinates and make sure that it works on the color, you do all of this one time, and then you just make sure that it continues to work, and that's it. So we've done a lot here. There's a lot of power, and now what we can kind of start doing is you kind of get to abstract that away, and now we just start dealing with down, right, left, things that make sense, and aren't that difficult to imagine. So this is very good. We made really good progress today. I know a lot of it was probably really confusing, but this is starting to come along. We're actually getting stuff moving on the screen, and we're getting our block set properly. The one thing we didn't do, which I guess I could go ahead and do really quick, might as well, right? Is we probably will get an error by doing it, but I want to see what happens. Is we need to try it with a different shape. And the reason I say we might get an error is because we might exceed the bounds of the array. So we'll do block 1, and yeah, cannot read property columns of undefined, and that's because this block references a row that doesn't yet exist, or that doesn't exist. So, well, actually, to combat that, let's stop with the erroring. We'll try that again, but we're going to move it down to 18, and now you'll see we actually get another block. And you can also use the same. Oh, that's what happens when you go off the screen or off the grid. I can't move left. So let's place that block back on the screen. And then we should be able to still do the move right and the move down, and it still works as expected. So we're starting to really get a lot of stuff built out in very little code, to be honest. So this is very good. A lot of trickery going on, but this is how games are made. So good work. I'll stop the rambling now, and we will take this to the next step in the next episode.